Okay, picking up where we left off with the diagonal one. What we'd done already at the vertical, and it was checking the row plus the ship size to see if it was greater than 10. If it was, then it had gone off the board. It was taking our horizontal and looking at the column. Obviously, if we're looking at diagonal, we need to look at both the column and the row. Now this is a diagonal in a particular way. So obviously we could do a diagonal one way and we could do a diagonal the other by looking at the row minus the ship size, or the column minus the ship size. So there's a couple of different ways of doing that diagonal. For this we're going to keep it simple, just one diagonal, simple. We've got the vertical in there, we've got the horizontal, so let's add an else if. So else if the orientation equals D, and then, and we can take that code that's already there, because scan is going from 0 to the ship size minus 1, so it's looking at each of those positions, and this one's looking at the column plus scan, and this one's looking at row plus scan. So this one, if we look at the row plus the scan and the column plus the scan, it's going both ways. If we test this now, it won't do anything because it's just validating it. Let's go to the play ship, and we'll add in a else if orientation equals D here, and then we'll put exactly the same in there again. And again, remember, row plus scan. And now this is only going diagonal in one direction. If we run it now, we should see, because we're not hiding our diagonal ship, we are hiding our diagonal ship, so we can't actually see if it's working. But remember, we can save it to a file, and I'm just going to call it d.txt, just to see if it has put one of our ships as a diagonal. And there we go, look, there's two ships as diagonals there. So there we have it. That's working diagonal from top to bottom and to right. If you wanted to add a different diagonal, which this goes beyond what the question paper says, what we could do, and let's have a look at this now. If we go back to our place random ships, and instead of having it out of 3, let's have it out of 4. And this could be, I'll call this D1. Else if HORV equals 2, then orientation equals, that's D1 and this is D2. So two different types of diagonals. We can validate the boat position, and again, let's add this in there. I'm just going to copy and paste for ease. But instead of doing the column plus the ship size, let's do one the other way. Let's take the column minus the ship size. So D1 does it like that, D2 does it like this. Let's copy and paste this. This is D1 and D2. So we've got column minus the ship size, minus the scan, and place ship. Copy, paste. Again, we've got D1, we've got D2, column minus the scan. Alright, let's see if that works. Yes, let's save it. Let's save that as d2.txt. Okay, let's have a look at our file now. It's not quite worked, has it? Place random ships. Let's have a look. Let's just random between 0, 1, 2, else. So we've got the D1, D2 orientation. We've got it as a char, look. That's why. So I'm going to call that a D, this one an E. Okay, so we're going to have to change the other bits to compensate for that. So validate boat position, D and E, D and E, and place ship. As I say, this is all trial and error. It's just a thought that came to me because we've got plenty of time on this video left. So I just thought, could we actually get the diagonal going in two directions? So we've got an index out of range here. So if the column minus the ship size, I suppose that's less than 0, isn't it? Rather than being, yeah, let's try that. All trial and error. Let's save it. Just going to call it DC for diagonal corrected. And look at that, diagonal in two directions. So this has actually got our diagonal ships put on there. We've got them going in two different directions. So it's just showing how we can take a program, how we can adapt that program, and actually think of any additional questions that they may ask us in the exam. So that's all those 10 questions as they are on those papers that I've come up with. The further one that I did possibly come up with was the idea of the FEN and counting the number of characters, counting the number of spaces. So that is something that we can look at in a moment. Okay, so let's add this save as FEN then. We're going to have this as a function to actually generate the FEN string. So the idea with this, I've not got the specification at handy, but please do refer back to your question. It was to represent the board in a different manner. So instead of putting the board in the file like we have done, to actually do it as one single line. So I'm going to create a function and call this generate FEN, and we're going to receive by val the board as a string. And one of the things I suggested was putting in the number of shots left, so as we can load this back up again. So I'm going to call this hits as an integer. So I'm going to create a FEN as a string. We're going to have a row as an integer, dim column as an integer, dim number of spaces as an integer, and it's going to work through. So for row equals 1, 2 size of the board, which is 10. I'm sorry, it's 0 to 9. We'll set the number of spaces equal to 0, and then we'll have the for column equals 0 to 9. If the board, how's the board structured? Row column, yep, it's like that, just double checking. If the board in the row column, so this is actually going to get the item from there. So if that equals a space, it's actually a dash on the board, isn't it? Then the number of spaces equals number of spaces plus 1. Else, so if it's not a space, if the number of spaces is greater than 0, so if it's not a dash, that means it's found a miss, a hit, or another ship. But if the number of spaces is greater than 0, then there had been some count beforehand. Then what we're going to do is the FEN is going to equal what was in it before and the number of spaces. We'll set the number of spaces back to 0. Okay. And then we will place whatever is in the board in that FEN. So we've got that for that bit done. The next part was when it got to the end of that next loop. So we've gone around each of the spaces, we've put everything in. What we wanted to do, basically, if the number of spaces there was greater than 0, then FEN equals FEN and number of spaces. I'm going to end that, and we're going to put the line on the end there. Right at the very end, FEN equals FEN and the number of hits, so it's going to add that. I'm going to return the FEN. Because I've done this as a function, we're just going to jump to the submain, and after the point where it is displayed, sorry, we're going to jump to the play game, make play move. Now, where do we play? Play game. Just after the bit where it's printed the board, I'm actually going to here output the generate FEN with the board and with the number of shots. So I'll return that value and it will display it. Let's see what this does. So we've just we've not tested anything yet. Oh, there's build errors. It's because I put that as a string. That should be a char. Silly me. So let's try again. Start a new game, and there we have it. There we've got our FEN. Now notice we've got the number 10. If we wanted to save this as a file, we've got the number of the hits there. If you wanted to save this as a file, then we can output that straight away to a single file.